In the vast, silent theater of the cosmos, humanity tirelessly pushes the boundaries of exploration. We chase distant worlds not with mere imagination, but with instruments of engineering brilliance and unyielding scientific ambition. For the first time in history, scientists wielding the James Webb Space Telescope have charted a three-dimensional map of an alien world. JWST-18b, a colossal gas giant orbiting a star some 400 light-years from Earth. This is no simple snapshot. It is a full 3D temperature map, a layered atmospheric structure revealing the intricate dance of heat, winds, and chemistry on a world of extremes, a world where even water molecules are torn asunder by heat. JWST-18b is a true behemoth, about 10 times the mass of Jupiter, and it completes a full orbit around its star in just 23 hours. A year on this planet is shorter than a single Earth day. Its orbit is so tight, so perilously close to its star that temperatures on its dayside soar to nearly 5,000 degrees Fahrenheit, hotter than the surface of some stars and hot enough to shred the very molecules that form water. This isn't science fiction. It's real data, measured and decoded by the most powerful telescope humanity has ever launched into space. To create this map, scientists employed a revolutionary technique called 3D eclipse mapping. As the planet slipped behind its host star, Webb meticulously monitored the subtle changes in different wavelengths of light. Imagine reading a world not by looking at it directly, but by watching its light fade, layer by layer, wavelength by wavelength. It's like peeling back an atmosphere one slice at a time, revealing its innermost secrets. These readings enabled astronomers to reconstruct the temperature structure across latitudes, longitudes, and even altitudes, essentially giving us a heat-based blueprint of the planet's atmospheric layers. And what they discovered is astonishing. JWST-18b has a brilliant central hotspot, a blistering region locked in a permanent stare-down with its star, surrounded by a slightly cooler ring. Unlike Earth, JWST-18b doesn't spin relative to its star. It is tidally locked, forever presenting one scorching face to the light, while the opposite side is cloaked in perpetual darkness. But the real shock wasn't just the heat. It was the planet's utter failure to redistribute it. On other hot Jupiters, powerful winds typically shift heat across the globe. Yet here, the heat stubbornly clings to the dayside. Any winds that might exist are either weak or trapped, unable to carry warmth to the nightside. This reveals something fundamental. The atmosphere of JWST-18b behaves unlike anything in our solar system. Governed by brutal gravity and intense radiation, a place where physics itself feels different. But the most dramatic discovery lies in the fate of its water. The dayside hotspot shows significantly less water vapor than the surrounding regions. Why? Because the temperature is so extreme that water molecules don't just evaporate, they break apart. The heat violently splits them into hydrogen and oxygen atoms in a process of chemical shredding, a phenomenon predicted by theory but never directly observed until now. For the very first time, we are witnessing molecular destruction on another world. Imagine an atmosphere so blisteringly hot that water cannot exist in any form, no oceans, no clouds, not even vapor. Reality itself is being pulled apart by heat. Yet, as hostile as this world is, this discovery is about more than just JWST-18b. It is about a new way of seeing. In astronomy, light is everything. It tells us about temperature, composition, motion, and even the potential for life. With this method, we now have a tool to map alien atmospheres three-dimensionally, to perceive depth, structure, and movement on distant planets that are otherwise just faint dots in the sky. The James Webb Telescope isn't just observing worlds, it is beginning to dissect them. This technique ushers in a new era of exoplanet science, allowing us to study planets we can't directly image, planets orbiting stars too bright for conventional photography. As this method is applied to more exoplanets, scientists will build 3D atmospheric catalogs, millions of data points that will ultimately help us answer the question that has haunted humanity for centuries. Are we alone? Because while JWST-18b is far too hot for life, the technology used to map it can also be used on more temperate worlds, worlds with clouds, worlds with oceans. Worlds where water doesn't break apart but pools and flows. Worlds, perhaps not so different from our own. Every scientific breakthrough is a stepping stone. Although this discovery focuses on a hellish giant, it sharpens our tools for the search for habitable planets. Technology that can detect broken water molecules on a world 400 light-years away may one day detect living oceans on a planet much closer to home. Every improvement in our vision reveals another piece of the cosmic puzzle, another mystery solved. We have journeyed from detecting planets as mere shadows passing in front of stars, to measuring their atmospheres, to now mapping them in 3 dimensions. The journey from blurry dots to full planetary portraits has officially begun. Today, WSP 18b reminds us that the universe is not always gentle, and not every world follows the rules that shaped Earth. Yet it also reminds us of what humanity is capable of, building instruments that stretch across space and time, decoding light that has traveled for centuries, and turning cosmic whispers into maps of alien skies. As we push forward, each new world teaches us something new, each discovery expands the boundaries of the possible, and each glimpse out there helps us understand home a little better. The first 3D map of an exoplanet is not the end, it is the beginning. A preview of the worlds we are soon to uncover, the atmospheres we will analyze, and the places we may one day explore. If we can map a world that boils its own water away, imagine what we will see when we find one that keeps it. And imagine what we'll feel when the first map we build is not of a fiery giant but of a calm, blue world orbiting a gentle star, a world that mirrors our own, reminding us that life may not be unique to Earth, but a repeating pattern written into the stars themselves. Thank you for joining us on this journey to the edge of discovery. If you want to explore more of the cosmos with us, please subscribe for more space documentaries.